Hi everyone, welcome to week 7. So this week we are going to start our quadratic relationship unit, and because we started the course with that spiral, so we were doing a little bit every day of the whole course, so every other day or every couple days we would kind of switch what we were talking about. Some of the stuff might actually be a review, which is okay. So some of it we may have actually talked about or touched on in the first couple of weeks of class, but now we're going to really hone in on it. We're going to really focus on it. So we're going to talk about quadratic relations, and you will remember that a quadratic relation here, so you need to recall that a quadratic relation is just any type of equation that describes a parabola. And remember that parabola, that's this like bowl-shaped curve, right? So we can have a parabola that looks like a bowl opening up, or we can have a parabola that looks like a bowl facing down, okay? So a smile or a frown. And all of these parabolas, or all of these quadratics, will have this general formula. So just remember that we've seen general formulas before, right? We're used to seeing general formulas in terms of a line. So one general formula that we have seen is the equation of a line, and that was y equals mx plus b. So now we're telling you that the general equation for a parabola is y equals x squared plus x plus c. But we have to add in numbers because remember with mx plus b, we can have numbers in front of our x and that constant. So those numbers are just any letters where they're just, those are numbers. So a, b, and c are numbers. But in the actual equations, you're going to see a number followed by x squared plus a number followed by x plus a number, okay? So let's actually look at that. So let's look at this example. In example 1, we're talking about the path of a ball. And this ball was thrown in the air, and it's actually going to look like this graph below. So it's going to look like this. So if I'm standing at a height of 2 meters, I'm throwing the ball. It's going to reach its maximum point here, and then it's going to start falling back down towards the ground. So the first question is, using this graph, what is that maximum point? So if I'm looking here and I'm using this graph, I'm just going to see where does this kind of start to fall down again. So it doesn't really look like it goes any higher than 9 meters. So I'm just going to look at the graph and analyze, write 9 meters in here. Okay, so that ball is going to reach a height of 9 meters. How far had the ball traveled horizontally to reach its maximum height? So now it's asking, how far did the ball go this way in order to get up this high? So if I'm looking here, okay, that's 9 meters high, but if I go down, that's at 10 meters. So in order to reach a height of 9 meters, the ball actually had to travel 10 meters horizontally, so 10 meters along a field, okay? And what horizontal distance did the ball actually travel before it hit the ground? So how far did we throw the ball, not how high? And if I'm looking here, if I'm looking at how far it went, I started at 0 meters, and I'm going to hit the ground. That looks like maybe 21 meters, your best guess there. So again, I'm just using my graph here to get these answers, okay? And I know that this is a parabola because of this ball shape, or sorry, not ball shape, bowl shape. Okay, so that means that it's going to be a quadratic relationship. So again, if you remember from our notes before, if I were to actually point out some key points on this graph, so let's look at this parabola shape. The very top here where it hits that maximum, we call that the vertex. And I can label my vertex x, then y. So if I'm looking at here, remember that my x value we said was 10 and my y value was 9. So I could say that this was my vertex, okay? Now, I could also say that down here, this is an x-intercept, if you remember that. So this is at 21 and 0, and that's because this is my x value is 21, my y value is 0, and yes, you just heard the weenie shake his ears. And so the y is 0 because there's no height here, right? I'm only dealing with that x-axis, okay? All right. Okay, so let's look at this last example here, or sorry, second last example. And in this example, it says that there is an arch support of a bridge. So it's that under part of the bridge that's supporting the flat piece that you would drive on or walk over. And this can be modeled by a quadratic relation of y equals negative 0.024x squared plus 2.4x. And at first, I think that I would probably shy away from this equation because it looks scary, man. There's a negative sign in there, there's decimal signs, and what are we supposed to do with all of this? But that's okay as soon as we know what these mean. And so let's continue reading the question. So it says, where in this question, y is going to represent the height of the bridge or the height of the arch support in feet, and x is going to be the horizontal distance in feet, so how far away they are from each other. A vertical support post is to be installed 40 feet from the base of the arch. How tall should the post be? So the first thing you need to do is graph this, and graphing an equation like this is going to be really hard if we were to make a table of values. So what I actually did was I used Desmos to make this, but just to show you the graph that's underneath. We can do this with math. So there's some things that we do know. So for instance, we know that the height, the maximum height here is going to be 40 feet, okay? And we know that, the maximum height is going to happen at 40 feet away. So basically, if this was my graph, I know that at 40 feet away from this point right here, this pillar, I'm going to have my post here, okay? So what that means is that our x value is 40. Okay? And we were given the equation y equals negative 0.024x squared plus 2.4x. So we're going to substitute or switch our 40 in for our x. So every time we see an x, we're going to write a 40. So in here, now we're going to use our calculators, and if I were to do 40 squared here, that's the same thing as 1600. And 2.4 times 40 is actually going to be 96. Okay, so now I'm going to do negative 0.024 times 1600. That gives me negative 38.4. plus 96, and all of this is going to equal 57.6, okay? So what does this mean? Well, this means that if x is 40, my y is going to be 57.46. So y equals 57.6. Well, that's my vertex there, or that should be pretty close to my vertex. So that's the maximum height there. So that means that this height is going to be 57.6. Now, when I plot this on Desmos, I see that it's a little bit different than what I'm seeing here. So if I plot this on Desmos, which I did right here, this is my maximum height, which is at 50 and 60. So my maximum height is actually going to be 60, but it's pretty close here, okay? It's pretty close, all right? So if I'm going to put that strut there, that support beam, it's going to be here, but that support beam needs to be 57.6 meters tall. Okay. All right. This is it for today's lesson. What you guys can do optionally, because this is an important part for next year's math and maybe later on this year if we have time, is to learn how to use Desmos. So I've given the instructions here for how to do this, and you're going to just follow the instructions and see if you can plot these curves. Okay. Let me know if you need any help. Miss you guys.